So just to summarize then, interpolation is of course concerned with approximating the values in between data points. Extrapolation is concerned with approximating values outside of a data range. Both can be achieved using similar methods in SciPy. The first of these methods is just to use either linear interpret, the interp1d function, kind linear, and to find any value can then be found as the interp1d effectively returns a function which can then be used just like any other lambda type function or any function generally to evaluate values at it. There is also a Lagrange option which would simply uses the interpolation data points to then use the Lagrange interpolation method as explained earlier. The spline interpolation is generally a two-stage process. First we must represent the spline as a spline object and then use the spline object in the spline evaluation. There are verification methods analogous in both MATLAB and Scilab. The Scilab commands are given here, and users who insist on using MATLAB are warned there is no Lagrange interpolation scheme therein, but there is a spline and linear available in the interp1d. You need to find x. Presumably x is the value, v is the interpolation points, xp is the data, and linear, but I refer to the interp1d help files in MATLAB if you're insistent on using it. For extrapolation, both of the methods, actually the interp1 method there is shown, which is great. Just to come back to that, so the first is the x data, the second is the y data, the xp are the things to be interpolated, and then the final thing is whether it's linear and whether you want to extrapolate. So we've worked those through by actually doing this extrapolation. Extrapolation is to calculate values outside the range. In SciPy, for instance, you would need to tell the interp1d that you want to extrapolate. If it's a spline extrapolation I should say, you need to ensure that you provide xb and xe as the bounds of what you can evaluate the function at. There is no specific Lagrange interpolation, but there is a p-chip analog available in MATLAB which has been used in these computations. So just to summarize, don't forget to complete the online survey. They will appear each Friday for you to have a look at. But you probably won't be able to do these yet until after the workshop sessions, so do ensure that you come to the workshop sessions. You link into these workshop sessions, very important. You should be able to recall the solutions to linear equations using matrix methods. There's no need to actually go through the process of inverting the matrix. The computer will of course do that for you. Describe and discuss the differences between the interpolation and extrapolation problems. We have gone through an example, but we'll revisit that example with slightly different values, of course, in the forthcoming workshop. We've explored ways in which to solve nonlinear equations using a variety of appropriate computational methods. It must be said that we looked at things like the Newton-Raphson routine, we've looked at secant methods, and we hard-coded those in Python, but then said actually there's more appropriate method to do that, which can be done for many variables for that matter, using the Python wrapper. And we explored some analogues in other codes such as Scilab, MATLAB and Maxima. Hopefully you should be able to use computational tools to perform interpolation on realistic data sets, and we certainly did that in the final example. And hence now you can see the importance, hopefully, of linear algebra, but also using vector matrices to analyse engineering systems such as blood rheology data. The references, I think it's important that if you're having any problems with the concepts, the mathematical concepts, K.E. Stroud's opening program does cover solution to nonlinear equations quite well. Learning the Scientific Programming in Python by Cambridge University C. Hill is an excellent textbook. For Scilab users, of course, XCOS. The Mastery in Ease is available through the library, and Peter O'Neill's textbook on advanced engineering mathematics does look in some way at interpolation schemes. Thanks for listening.